Welcome back. After about a year of gathering dust, I've revived this project and I think it's time for me to give you a proper introduction. This model will become a radio-controlled boat and it has the unique feature of being propelled by Magneto-hydrodynamics. In other words, at the heart of its propulsive system are two large neodymium magnets. Those magnets project their flux into the water around the boat, and then by adding electrodes I'm going to send current through the water, which will be salt water, and that will produce thrust. As with the previous proof of concept, the flow and propulsion will all be external to the hull. There will not be any ducted flow found in many magnetohydrodynamic thrust systems. At some point I will discuss the design of this hull. You'll note, of course, that it is very chubby, round, and exactly the opposite of what you would expect from a very efficient hull shape. To make my MHD project remote control, I'm going to strip this toy of its remote control parts and incorporate that into my design. It doesn't have a rudder. Instead, it has two screws, propellers, and it steers by thrust vectoring. It's a very basic system. The motors are either on or off. There's no actual speed control, so you just have both on at the same time or one on at a particular time. For my MHD project, I actually think this thrust vectoring method has merit. The whole advantage of a flush electrode MHD drive is that you don't have any vulnerable moving parts externally. So by eliminating a rudder, that's another moving part that can be eliminated, and the hull can be made extremely smooth with very low wetted area. What you're looking at here is a mock-up of the entire propulsive system, including all the power and electronic components for remote control. The remote control circuit comes from a toy boat. Its power came from a 4.8 volt NiCad battery, which also supplied power directly to the motors. I'm using this circuit to switch to MOSFETs, and thereby can switch much higher voltages and currents than the original toy remote control circuit. I'm afraid that when I demonstrate this, the radio control signal will interfere with the camera's microphone, so I'm just going to mute that buzzing noise for the video. Right, so there's two channels, simply on/off on each channel, no actual speed control, and both channels on, and then port and starboard. Let's now push this up to 12 volts. Let me zoom that in for you. Full ahead. The residue in the water unfortunately makes it very murky. Just as a teaser of another video coming up, I'm going to add some rheoscopic fluid, and hopefully that will help us to see the flow better. This is epoxy pigment mixed with water, and also a small amount of dioxidine, which is a rust remover, and the primary component is phosphoric acid, if I'm not mistaken. The dioxidine acts as a surfactant, which helps the pigment to stay suspended in the water and not just sit on the surface. It does unfortunately cause a little bit of foaming, but let's see how it goes. That dioxidine is causing way too much foam. We can't see anything on top, so let's have a look at the flow from the side. Okay, there you have it. So coming up in the next video, I'm going to create a very unique rheoscopic flow that will also indicate the direction of the magnetic field.